Hello, I'm Pete Howard from Altran, and this is a talk about software engineering. We're going to be using this app here, which is a screenshot of, as our use case. It's a graphics app, as you can see, and it's for engineers who are taking an interest in the airflow inside the components in engines. And I'm going to give a quick 4-second demo rather than actually try and explain it in words. This is a turbocharger, this is an airflow meter, and this is the air that flows from one to the other. If I want to add a new component, I say new node, drag it to where I want it, say I'd like a new link and connect it up like that. The code is written in Java, and the way we're going to discuss it is I'm going to demonstrate one of the features of the app, or one or two, and then we're going to go and look behind the scenes, and we're going to take a particular interest in the design patterns that are used in the architecture and the coding style and approaches, and in particular the reasons why I think those coding approaches and styles might be of interest to people. To give you an idea of why I'm doing this presentation, these are the reactions that in the ideal world I would hope to elicit from developers. So I'm hoping developers are going to say, well, I wish our software was like that, because if it was, new developers would be able to get started much quicker on our work, and then that would mean that we could bring people into projects when otherwise we might say, well, it'll just take them too long to ramp up. It solves that problem. I'm hoping developers are going to think, if our code was like that, it would be easy to change. And that would make you much more inclined to change an app, because it would cost less and there'd be less risk. And I think it's going to show that the code written like this is easier to test, and that means that people will write more tests, and you get a sort of cascade of benefits. You get fewer bugs, you find your bugs faster, your releases are more stable. The tests have a self-documenting effect, so new developers can contribute more quickly. And you'll also see, as we go through the code, that there's a very great many reusable components created as a side effect, and these build up cumulatively over the months and over the years, and so the overall cost of development as time goes on actually goes down. And you can also create what you might call a kind of crown jewels components, and the best-in-class components for a particular job, and then if they're reusable, all the apps that you develop in the future in the same language can benefit from them. I'm going to get started with some demoing of the ways you navigate in terms of zooming and panning and that kind of thing. Panning is very easy. It's like Google Maps. You just grab a bit of the screen and move it. I think that's a very intuitive model. Zooming, you just pull a rectangle with the right mouse like this. And if you want to zoom back out again, you press F5. So that's pretty straightforward. And you can't help but notice that there's these three separate windows, and these are splitters. And they're all views on the same model. If I were to go and highlight that thing there, you'll see in the views below, just there, that's the same thing, and just there, which has a really big practical application. Say, for example, I wanted to connect a link from this thing here over to, say, that one there. What I can do is I can zoom in like this there. I can zoom in on that one. Oh, I beg your pardon, not there. I'll zoom back out again. I can zoom in on the same thing down here. And then I can see the big picture up here, but the small details here. So I can say, let's have a new link. It's nice and clear because any link that isn't connected is a different color and has a big fat blob to pick on the end. And I can move it near to where I want and it will appear in the view below, and then I can switch to the view below to finish the job. So I'm hoping that those few features alone make you realize that there's really quite a significant bit of code and design to be thought about here. We're going to be demonstrating it in plain Java, so all you've got is a canvas. You might wonder why we're not using a framework. And the answer is, well, we are actually. There's got another project where we are using the Java NetBeans Visual API. But the whole point of this project on the side is to explore what the implications would be of doing it in plain Java. What I mean by doing it in plain Java, we have to realize is all we're going to be given by Java is a rectangular screen to draw on, and tools which let you draw lines and arcs and shapes on it, and of course putting text on it. And it's willing to tell you when the user clicks or moves the mouse. But that's it. To create a more sophisticated user experience, you're on your own after that. So as we begin to look at the code, we're going to start looking at some of the most interesting things first. And I think probably the most interesting thing is the fact that we've got 3 views into the same model. And this is a place where we can deploy the good old model view controller pattern, except we say views in the plural, model views controller. And the way we've implemented it in this source code tree is that we have a display subsystem in which there's a model, which is this thing. And you can see from this slider, there's not an awful lot of it. It's a container, and it has arrays of links that are going to be displayed, a background image. If there's a highlighted polyline, which you'll see later, this is where it lives. So it's a fairly simple container. The view in the model view controller is this thing. And again, the scroll bar tells you all you need to know about how big the class is. It's not very big at all. It's an extension of a panel. And it will have a paint component method overridden, and that's just about it. The controller is admittedly a little more complex, and the main thing it has in it, it owns lots of objects which give it, because it kind of sits at the root of the graphics subsystem. But the main method in here is this one: apply zoom and render the current display model. And the final design pattern I'm going to speak about in this section is how we deal with zooming from a maths point of view. If I pull a zoom window in here, note that this window here is essentially long and thin like a letterbox. If I pull a zoom window which is the opposite, it's tall and thin, like that, it still works all perfectly sensibly, and we have to ask ourselves, well, how did you do that? Well, the first thing to note is that in addition to the app itself, there's a widely reusable utilities library down here, which has got quite a lot of stuff in, and this was the point I'm making about generating as a side effect a whole bunch of reusable utilities. And the notion of zooming is obviously something that could be used in many applications, so it's quite important to design it so that it can be used in many applications. So in our little zoom subsystem, we've got a class which is capable of doing this: calculate a transform for a requested zoom window. And you pass in the zoom window that the user has pulled, and also how big the area on what shape the area of screen you want to render into is, and it gives you back a transformation, a matrix transformation. But because the rectangle that I zoomed was one shape and the rectangle that was available on the screen was another, somebody's got to decide how to reconcile those two and decide what transformation to use. And that's the thing, aspect ratio adjuster, and it's got a simple adjust function. I think that's really quite a nice example of how an entire little package to do the zooming maths can be completely separated and just dropped into another project, and it will just work. Now you'll see that I'm showing you a finite state machine now, and I just want to introduce the concept of those and explain how we're using those. And this is to do with the fact that there's a great many interpretations of mouse events. Even in that tiny thing at the beginning you saw, there was zooming, panning, right clicking and so on. And as the demonstration goes on, you'll see that there's a very great many interpretations of mouse movements, and so we need something to organize that. And the finite state machine is usually represented by one of these diagrams. It's actually a UML standard. And this one I've taken from the Android documentation, and it tells you how you have to use the library if you want to use the multimedia recorder. And what it says is, these ovals are states, and these are state transitions. And what it says is, it will come up in the initial state, and if you want to get it out of that state, you have to call these methods, and when you call those methods, it does come out of that state. If when you're in this state you called the reset method, it would take it back to this state. And if you called the set output format method when you're in this state, it would take you to this state, and so on. So it gives you a completely unambiguous navigable map of the behavior that you want to go from one state to another. And it's a very useful tool for software development because it provides a way of communicating what you want behaviorally in a diagram. And then it's quite possible to organize the code to match that, which makes testing and maintenance and modification much easier, particularly modification of behavior, which is usually difficult for new programmers to do. And people seldom organize their code according to state machines, even when what they're doing is really implementing a state machine. I just want to show you quickly how we've gone about that. Once again, the code is in the widely reusable utilities library for the same reasons as I said last time. Here's the finite state machine. And it's a completely reusable machine with some instructions here as to how to use it. Oh, I beg your pardon, that's a state, that's an interface. What I should have started with is this one. There's a state machine with instructions on how to use it. And you instantiate one of those, you don't have to extend it. But when you want to put states into the state machine, you have to provide classes which conform to this interface, which is a very good example of how you can use interfaces in Java. And I'm going to go and show you the states that we used in our app. So I've come back to the code tree for the application itself rather than the utilities, because clearly the states are specific to this app. I have a little folder for the states, and we have two. The first is a dragging state. So this is the code that says when the mouse goes over something in the dragging state, it should be moving something. Whereas when it's in the passive state, it says if you move the mouse, we'll see where you've ended up over and do some kind of highlight to highlight it. And I think that's probably enough for the first session. Give everybody a taste. I've put my contact details on there if you'd care to speak to me. I'm always keen to be contacted by people with similar interests, and give advice if people would like that. And now this is one of a series of videos, so hopefully it's pricked a few seeds of interest, and hopefully you'll look at the next one. Thank you for listening to this one.